All right. Hello. Hello, everyone. How are we doing? Sound test. Sound test. Beep, 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 beep. I think we're good, no? Uh, Hello. What's up? How's everyone doing? Oh, it's been a while, right? It's been, what has it been? It's been 2 weeks. 2 weeks. Um, and I see a lot of familiar faces. Dusko, Andres, Monique, how are you doing? Good to see you. Sherman, I don't know if we know each other. Welcome. Parastom Arastu, how are you doing, sir? Good to see you. Kartik, good to see you too, man. Lara, Archie Coder. Oh, I've seen you around a lot lately. And Kiran, what's up? Ah, oh, what? Monique, what is that? What is it, the diploma that you have finished? Ah. What diploma? Can you let us know what diploma? And then, well, congratulations, Monique, for finishing a diploma, whatever. Um, but I'm assuming if you were doing a diploma, if you were studying, that was also cool. So you have time to do more cool stuff now. All right, are we doing cool stuff today? Hopefully, we're going to do some cool stuff today. All right, I may have to leave in a second because I'm still brewing some coffee decaf, of course. Huh? Um, and um, and what are we doing today? Thanks for being here. It's been a couple weeks because last week, 2 weekends ago, it was my birthday. So I took it off and I celebrated, and it was great. I actually had a great time. And last weekend, I had a personal issue, so I couldn't really jump on the stream. But we're back. We're back on track. So we're back on track. With today, what we're going to do, what are we going? Well, let me pull up my notes. You know how I have notes. You know how I have OCD, so I need to have notes and all this stuff. What are we doing today? Yes. So today we are going to. Yeah, yeah, that's too exactly. So I went scuba diving, and I actually caught some lobster. Oh, actually, let me show you. I have a friend. I have a friend who, because I was so annoying with scuba diving and lobster fishing, he actually gave me this lobster puppet, which kind of matches really well with the whole environment, right? How cute is this? Huh? I still have to give it a name. So, what is it going to be? Roberto, Sebastian, like the Little Mermaid, right? All right. Nice engineering thesis. Congratulations, Monique. That's pretty awesome. All right. So, what are we doing today? Well, first of all, quick reminder if you are new to the channel, what are we doing? Yes, if you're new to the channel and you haven't been here before, we do live streams every week, more or less, with exceptions, on computational design. We record tutorials here live. I chat with people. We do cool stuff. But we also have an offline. We also have an offline. Is this true? We also have an offline server, a Discord server where we have conversations going on during the week. So I'm going to copy paste the link here. All right. Thank you for all your birthday wishes. Oh yeah, sure, mean you're right. You're right. You texted me on. Yeah, you're right. Welcome, welcome here. So we have a Discord and we have like offline conversations every week. We also have a calendar, a Google Calendar that you can subscribe to if you want to know when the streams are going to be. I'm just pasting it here in the chat. I also typically announce that on my Instagram and my Twitter. So if you want to follow that, actually, yeah, in my Twitter. Well, we also have Twitter and Instagram here for Parametric Camp. So if you follow that, you will probably get notifications about when we're streaming. And I want to do a quick thing today before we start. I want to give a shout out to my friend Nono Martinez Alonso. Maybe you know him. We've worked a lot together in the past. We've taught workshops. We've done online things. We've written. Have we written papers? I'm not sure about that actually. Anyway, but he runs this project called Getting Simple, which is about doing more, no, doing less better. Yeah. So it's doing less better, right? It's about like focusing on like what are the right things to do, when to do them, methodology of how to do them, and living a simple life. Basically, he has a lot of interviews with really smart people, and really interesting interviews about life, about work, about balancing things. It's very interesting. A lot of people in the computational design world as well as part of the interviews, and he recently started live streaming. So I believe he did a live stream recently where he was just like, "Hey, hi, we're going to do this, whatever," and he's going to be doing a lot about sketching, a lot of things about artificial intelligence, machine learning, tutorials, hands-on. So if you like those topics, you should definitely check him out. It's really good. It's really good content. I have to say, like, I chose the red color first, but let's not play that blame game. You know, that's not what we want to do today. Anyway, so what is it that we're actually doing today? So if you remember, we were halfway through this course or this playlist of this set of tutorials that I was writing called Learning C# for Designers. Okay, and I was explaining the basics of how to write computer code from scratch, no assumptions. I'm going to teach you everything. And I was using C# as the programming language because I think it's a nice introductory platform. It's strongly typed, which I think is good for education when you learn programs, and it also integrates really well with most of the design software or like computational design software that I see now being used worldwide. So it integrates really well with Rhino and Grasshopper, integrates really well with Dynamo Beam. It integrates really well with Unity, and it's very also, if you know C#, it's very easy to jump to other platforms such as, for example, processing, right? So there's a bunch of advantages to that. So I'm using that as a startup point, and and so I was like halfway through. Oh, my coffee is ruined. I will be right back. 1 second. Alrighty. Yes, I'm back. So Um, what was I saying? Yes, so I was in the middle of that. So today we're going to continue recording tutorials for that list. I'm going to be talking today about functions. So I'm going to discuss how to create what they are, how to create them, some rules of how they work, best practices perhaps, and I will end up doing like a longer exercise perhaps where I will just implement like a bunch of functions that do different things to basically explain and showcase how they work. And then today we're doing a double live stream. And in the afternoon, I will probably not have finished during this morning with functions. So maybe whatever is left, we do it in the afternoon. But I would like to do a geometry jam today because at the class that I teach at Harvard, we're going to be doing a lot of meshes very soon. So I would like to record a couple of tutorials on geometry jams about generating point grids, creating meshes by generating these point grids of points, and I would also like to explain a little bit of like mesh manipulation and things that you can do once you have a mesh. So I think I want to record like a set of gems in that sense. So I may start doing that, and maybe next week we just do those. I don't know. I'm thinking about it. Okay. So we're there. Also, I want to highlight the fact that I just got a completely new setup. So I'm streaming from a new. I bought a new computer, new screens, new keyboard, new graphics card, new setup. Most everything is new. So, and I just started using it like a few days ago. So we may run into technical issues. I also have like very little software installed right now. I only have the basics, but I do have a system now to draw sketches into the diagrams that is a bit more. Look, take a look at that. So you see, if I change, where am I? Yep. Yes. So you see this? How clean it is right now? And actually, I don't have to go anywhere farther away now. Now I just like, look, oh, blah, 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 look. And then look, this is a square, and this is another plane, and this is a vector. Pooh, you know? It's like super clean, super nice. I'm very happy about this. Chandra, are you calling me old? Did you just call me old? Did Chandra just call me old, professor? Is that what you're saying? So disappointed. Is that because it's my birthday and you're calling me old, Chandra? Alrighty, so I'm very excited about this. So any question? Oh, and as usual, I know, I'm joking. I'm joking. And as usual, I will do Q&A and some social, probably by the end of the second live stream in the afternoon. Okay. Hey, Barbara. Good morning. How are you doing? What, Chandra? I know. It's a joke. Don't worry. Don't worry. All right. So where was I? All right. So let me get set up with stuff. So, okay. I'm here. Mm-mm. Ah, it burns. Ow. Ouch. Ouch. Mm. Okay. So functions. Functions. We're starting with functions. Let me actually wait. So let me actually check out where were we in terms of the playlist. So we were here. No, I want to see the playlist. How do I go to the whole playlist? There you go. So yeah, stop this. And for those of you who might be new, this is Learning C# for designers, mostly because a lot of the examples that I will be doing will relate to somehow to geometry or computer graphics or that kind of stuff, because that's where I want to end up getting all of us better. So, but computer programming is computer programming for designers, for computer scientists, for research, for everyone. So there's not really any difference beyond the examples that I will be using. So we were introduction to data structure, lists, classes of objects, iteration for loops, iteration for each loops. All right, conditional switch system. And yeah, and this one is going to be pushed somewhere. And am I doing any example about this? No, we're just, but Lara, it's fine. You can just catch up. Just like watch this. Don't watch the live streams. The live streams like take forever, and I'm going back and forth, blah blah blah. Just watch all these videos, boom, and then you will just catch up to where we are. So I should be starting with 8.1, intro to functions or something like that, right? And then I probably want to talk about. I probably want to talk about. Um, hmm. Programming guide, main and command line, argument, statement, special operators. I guess it has to be methods. Yeah. You know what? I'm actually going to draw a diagram, like a very simple one, where I'm going to say, you know what? It's just actually very simple. A function is something that takes the function is something that takes a bunch of inputs and returns an output. And then these are inputs and this is outputs. Huh. I love this new drawing thing. And this is a function. I really like the new drawing gig. Yeah. All right. I may just talk about that when we are passing by reference and by value. Yeah, we can't talk about that yet. Yes. So I may just do a small piece talking about what a function is, and then I will show this, as in like this is what I want you to think. A method is something that just takes something, and then I will start explaining how they work. Yeah, I think that's where I want to be. Components, yeah, exactly. Like Grasshopper components are functions, and we will get to that somewhere down the road. But yeah, exactly. A Grasshopper component is literally a function, just simple as that. Alrighty. So should I start? Okay, let's start. Oh, I see a lot of people signing up for the Discord. Nice. Okay. All right. So, okay, I'm going to shut down the Discord because otherwise I get super distracted. All right. Let's start. The audio is fine, right? Yeah. Hi there. So in this new section, I would like to go over the topic of functions, okay? And when it functions, I would like you to think of functions as something very simple. A function is going to be something that is going to take some data in, is going to perform an operation with that data, and then is going to return something back, okay? The idea is that when we write functions in any computer programming language, what we want to do is we want to basically encapsulate in some form the idea that data that is coming in can be processed and can create an outcome. And this concept is very, very important in computer programming because it leads to it leads to something that is considered really good practice in computer programming, which is encapsulation and modularity. The fact that when you're writing an algorithm, for example, if you have an algorithm that is doing many, many different processes and you end up writing like a ton of code, a lot of lines, it can be messy and it may not be that reusable. So if your algorithm has like very distinctive functions or very distinctive parts or processes that need to execute, sometimes it's very convenient to take that particular subset of operations, extract it from your main code, and then turn it into a function in something that is very discrete, very understandable, and very contained among itself, right? I will I will show examples about what this means, right? And I just want to say that if you want to take a look at, in general, how functions work, feel free to go here to the Microsoft documentation, to the section that says methods. And it's methods because technically all functions in C#, they always belong to a class. And that's why they're called methods. But for the time being right now, let's use the term method and functions interchangeably until we get farther down into this series and I talk about object-oriented programming, and I can be a bit more explicit about what a method actually means in relation to a class. Okay, but for the time being, methods and functions, pretty much the same thing. Okay, so let's take a look at how to write a simple function in C#. Let's move on to the next video. Alrighty. Next video. I'm going to shut this down and I'm going to open. Where am I? Yes. So here, I need to create. Oh, I need to create some files. Probably. Oh no, I'm not recording. Oh damn. Okay, so we need to record that again. Sorry. Okay, so let's start recording. Okay, so now I'm recording. You see, I knew there was going to be. I'm recording, and the settings are right. Okay. All right. So now, okay. So C sharp. Okay. So no here. Okay. So let me start over again then. Uh, well, that was lame. Hey, Miguel. Good morning, sir. Okay. Let's do it again. Hi, and welcome to this new section where in this section we're going to discuss the topic of functions. All right, and functions are extremely important in computer programming because they allow us to do one of the things that is considered best practices in computer programming, which is encapsulation and modularity. What that means is that, well, first of all, a function, I would like you to think of a function as an operation that takes some data in, performs some operation with that data, and then returns back some results. All right. The idea is that when we have, for example, a very complex program that has a lot of operations, an algorithm that is doing a lot of different sub operations or sub algorithms, right? If we were to just write everything one after the other, the code might get messy as the program grows in complexity, is very hard to maintain, and it's also not very reusable because there is a very strong likelihood that very similar operations will be used in many different places. So the idea is that extracting smaller, more contained operations and turning them into standalone functions that we can reuse anywhere in our code is considered really good practice because it leads to modularity. So I can now copy and paste and reuse that function everywhere. If I need to improve it or if I need to debug it, I can just do it in the functions and it doesn't affect the rest of the program. But it also makes writing code much cleaner and much more readable. So we will see a lot of examples about that. And also it leads to making the code more usable because if you're using somebody else's functions, maybe you don't actually need to get into what code is running inside of the function. You just want to use it. So that's why it's a very functional, if you will, a very functional way of approaching that. So we're going to see a lot of examples of how that works. But if you're interested in reading more of the technical aspects of functions, please, you can go to the Microsoft documentation for the .NET language and where it's called, and in this case, they're called methods. But for the time being, I would like you to think of functions and methods as pretty much the same thing because we still haven't talked about object-oriented programming and classes. And it will be there when I will explain exactly why functions are called methods as opposed to just functions, okay? But they're pretty much, for the time being, we can think of them as pretty much the same thing. So let's take a look at how to write simple functions using C#. So let's take a look at that in the next video. Alrighty, so okay, so now in the next video, I'm going to open Visual Studio and I'm going to create a new project. It's going to be a console application. And what is this going to be? So it should be probably what is the name going to be? It's going to be 41 simple function. And it's going to be, I'm going to just put it on the desktop because I'll just move it later at some point. And .NET Framework point, what was I doing before for the other videos? Point 45 is just fine. How's everyone holding on? You haven't told me how was your week. We haven't seen each other for long. How was your week? How was all this time that we were apart? Tell me how is that going? How is COVID looking for you these days? Okay, so we are here, and I'm going to console read key, and this is going to pop up on my other screen. So I'm going to do this, and then let system position. Do I want to customize this? The height, the buffer, the width, the height. I think that's fine. No? But let me write something. Console write line. Hello there. It's literally the first time I use Visual Studio on this computer. So hello there. Do I want this or do I want like some different colors? I think I want this. But maybe I want the typeface a little larger. Yeah. I don't know. Yeah. Well, hello there. Yes. Probably we want this a little larger for the streaming. Maybe even larger. Is this too much? I kind of like this. Yeah. It's easier to read for you, right? All right. So we're going to do that. And then I'm going to create double A is going to be equal to 10, double B is going to be equal to 23, and double sum is going to be equal to A plus B. All right, and then I think I'm going to build up from this into what a function is. Okay. All right. Okay, so what is the next thing we're doing? We're writing a simple we're writing a simple function that is going to add two numbers. Okay. And then I'm going to do this. So I think we should be good here. Let's get ready. All right, so let's start by creating a super simple function, okay? And I couldn't think of anything simpler than just adding two numbers, for example. Let's imagine that for some reason we have an algorithm or a program that is going to be adding numbers very often. And let's imagine that we didn't have like the simple addition operator, which is definitely what we would use. And we wanted to create a function that can add two numbers together and can give me that result back. Okay. The way that we would do that is by defining that operation, defining what kind of inputs and how many that function is going to take, and then defining what the result of that operation will be, and then implementing that code in the function. What does that look like? Well, the first thing that we're going to do is, let's look at this program that I have here right now. I already have like a template for, I have two numbers here as doubles, and then I have that operation, which is adding the two numbers, and I'm printing that to the console so you can see the number 33 here. Okay, but what I want to do is I want to replace this with, instead of a hard-coded operation, I want to abstract this operation into its own function. Okay, So the way I'm going to do that is by going all the way outside of this one function here, okay? And I'm going to go back to that root. And then what I'm going to do is I'm going to define here in this scope, I'm going to define that there should be an operation called addition that takes two numbers and return a third number that is the sum of them both. The way we do that is very simple. The way we do that is first, we're going to define the function by defining its name. So I'm going to define that the function is going to be called addition. Then I'm going to open and close parentheses. I'm going to open and close curly brackets. And it's giving me errors because we're still not there yet. But you're already pretty familiar with this idea of like open, close parentheses, open, close curly brackets to define things. Then what I'm going to do is that here in the parentheses, what I would like to say is that I need to specify here that this function is going to accept two values that are going to be numerical. And because C# is a strongly typed language, we need to specify that those are going to be numbers or integers or strings or whatever they are. The way we do that is by typing, well, my function is going to take two numbers. So whatever is given to this function first is I'm going to call it the value A. All right? Sorry, value A. And I need to specify that this is going to be a double. All right? And I also want to specify that my function may accept a second argument, a second thing. I'm going to refer to it as value B, and it's also going to be of the type number, of the type double. All right? These two things here are typically referred to as the arguments of a function. So what are the things that a function takes as inputs, all right? And basically what I'm doing is I'm giving them placeholder names. I'm treating them as variables, if you will, so that when I write code inside of the function, I can refer to that data that is coming in by these variable names that I just wrote here, all right? Now, the second thing that I need to do is I need to specify that whatever is going to get is going to be thrown back to whoever calls this the output of the function, what type that output is. And remember, that is because C# is strongly typed, so we need to always specify the type of all data that we work with. Because we're adding two numbers together, the result is going to be also a number. So the way we specify that output is going to be a number is going to be by writing the type of the data that is an output before the name of the function that we just created. Okay, and then another thing that we need to add, and for the time being, I'm going to ask you to just trust me on this one. It will take me, I will not be able to really explain why this is the case until we reach object-oriented programming and classes, right? But for the time being, for this particular example in a console application, we will need to add the keyword static to the beginning of the function, okay? Just trust me on this one. For the time being, I will explain further down in this series why this is the case, okay? Okay, we're ready. So we have the skeleton of a function that takes two numbers as inputs and returns a number as the output. So now what I need to do is inside of the function, I need to write the code. I need to write the algorithm that is going to perform that super high-level calculation, right? And what that's going to be is I can do, for example, what I can say is I can create inside of my function, I can create a variable and I'm going to call it added or whatever, I don't know, it doesn't really matter. And then I can say the result of the value of this value has to be the value of the two inputs that have been given to this function combined as a sum, all right? If I do that, you can see that I should probably think that my code is ready, but it's not ready yet because if I go over the error that the compiler is giving me, it tells me that not all the code returns a value, which is a weird thing. But I want you to imagine that in this algorithm, instead of being like a simple addition, it was like a million lines of code, right? Where we're doing a lot of like really complex operations to find the output, the result. If that was the case, the computer would not really know from how would the computer know from those 1 million lines of code, which is the actual one value that needs to return back as the result of this function, right? The computer cannot know that. So it's us. We have to specify what is it that it's the result that we want to throw back as an output from this function. And the way we do that is by using what's called the return keyword. It's just as simple as saying at the end of the function, when you're done with your calculations, you write here return, which is a special keyword, and then you, after that, you return what is it exactly that this function should be outputting. In this case, it's going to be the value of the variable that we have defined called added. Okay? And I see that there are no more errors anymore here. So that's great. So how can we now try if this works? Well, the idea would be let's substitute here a and b, and let's substitute this by my new function. You can see how addition it now shows up as part of what I can do in my program. And then I open parentheses, and then I say, well, I want to add here the values of a and b. All right. And if that's the case, then when I execute my code, I get the result of the value of 33. All right? How awesome is this? Uh-huh. How was that? Was it clear? Difficult? We're going to do a lot of functions today, so it's going to be great. So now, what do I want to say about this? I think I want to reinforce. I want to specify here what is happening. So the idea of like data goes here, but I want to like trace the path of the data somehow to make sure that we know what's going on. And what else do I want to do? Do I want to do more examples? Do I want to do more examples? Maybe or not. I may want to do a couple more examples where the data types are different. Yes, so maybe I want to do that. Okay, so before that, let me go over this again. Do I want to talk about commenting functions? About smart comments. Do I want to do that? Is it better to do it here, or is it better? I think it's better to do it here because it's the first time really that we have yeah, I think yeah, smart comments. We're going to do that. Smart comments. How is this called? I actually don't know what the proper name for that is. C# comments for documentation. Documentation to document their code. Documentation comments. Okay. So not smart comments, but documentation comments. Okay, so I think we're going to do a piece on this one because it's kind of nice. So we're going to do that. How is everyone doing? Yeah, Karthik, I know. I have a lot of friends in India, and the situation is not looking great. But it's not looking great anywhere. Lara, you're gonna share some data? You're gonna share some links to that exhibition? We would like to check it out. Feel free to do that on the Discord. All right, let's talk about where the data flows here. I want to take a second to make sure that we understand exactly step by step what's going on when we call this function and how the data is flowing. If we think of the main program, right, we know that we declare two variables, they have those values, and then we have this function call here. If you remember when we discussed statements, we discussed that statements are typically executed from the right-hand part first, And then, especially when it comes to declarations and assignments of variables, the first part that gets executed is the right-hand most, and then that gets assigned to the value of the variable. So what's happening here is that when we reach this line of code, the first thing that gets executed is this part of the statement here. Then the computer jumps to the function declaration, and because the value of A is 10 and the value of B is 23, what the computer does is that it jumps to the function declaration, and then it assigns the value of 10 to the variable value A, and it assigns the value of 23 to the variable B, to the variable value B. So that when I am inside of my function now, value A and value B have those values that have been passed in here as arguments. Okay? They get added together, they get sent back as outputs of this function as a number. So at this point, this is the value of 33, and this whole thing, because it's the output of the function, it becomes the value of 33. That value of 33 gets assigned to the newly declared variable called sum, and from this point on, in the value of in the life of the program, sum has the value of 33, and so on and so on. I think what I want to highlight with this is that what's interesting about functions is that we basically declare placeholder names for anything that gets sent in, and therefore we can use them inside of the function. And we do that by somehow declaring kind of variables on the fly that will be used inside of the function, and then they will expire, they will cease to exist once the function is done because of the rules of variable scoping. And we have videos up in the series where we discuss that topic. Okay? Therefore, the fact that this is called A and B has nothing to do with this being called A and B. I could actually call this A, I could actually call this B, and it will work exactly the same. And these two names don't have to do anything with these two names. And so actually, I'd rather name them something different to make this a little less confusing. Okay? Hey, no. Good morning. I just gave you a shout out to your channel before and the new live streams you're doing. um, yeah, you saw that before. Yeah, yeah, yes, exactly. All right, so what are we doing now? What are we doing now? I'm doing another example with some other data type. And that's going to be, for example, what is it going to be? It's going to be create a greeting message, for example. All right. Before we discuss other topics, I would like to do a really quick example, another quick example with some other data type for the function. Just for the sake of illustration, even though by the end of this section, I will be doing like a longer exercise where I will implement like many different functions, and I will discuss like the nuances and different ways we can do these things. But for this one, I want to do something simple. I want to create a function that, given the name of someone, it can create a greeting message. Okay, so for example, what I'm going to do is I'm going to create a function that is going to be called greet. And what this function is going to take as an argument, remember arguments are the names that we give to the inputs that are coming into the function. It's going to take a string, it's going to take some text that I'm going to refer to as name, all right? And then what I want is this function to take that name and create a full message of the kind hello name and then like an exclamation mark maybe. So the return of this function will probably also be text, and therefore I want the return type of my function to be a string variable. And as I said before, Please trust me on this one. For the time being, in console applications, we need to define functions as static members. But we will get to that, why that is the case very soon. So here inside of the function, what I just need to do is like very simple string concatenation, where I say, I'm going to create a message, and the message is going to be hello with a white space, plus the name of the person that is coming in, plus an exclamation mark, for example. Or if you are interested in, for example, string interpolation, you can write the same thing by doing string message, and I believe it, I always forget what the syntax for this is. Hello name, and then, all right, whichever mode works better for you. I don't know. Okay. And once I am done composing my message, I can return this this variable. Okay. Therefore, what I can do here is I can say string greeting message is going to be equal to greet, and for example, hey, greet Jose Luis. All right. And then what I will do is I will print to the console the greeting message that I just created. All right, let's see if that works. Okay. All right. Yes, we do have a message here that says, hello, Jose Luis. All right. Remember again what's happening. This string gets sent to the function. It becomes name. Then I can operate with that. I can create a new message, a new string, and then send that back. All right. Also, when I teach, I like to be very, very explicit and break down all the possible steps. But you may actually, for very simple operations, you may actually shorthand. You may actually want to shorthand these things. So for example, something that you could do is here, you may want to say, well, instead of creating a variable, adding things together and then returning that variable, something that you can do is you can just say, I'm going to here, oops, I'm going to here, sorry, I'm going to return the value of value A plus value B. All right. This that I just did is the exact same thing. It's just a little short-handed. Similarly, I could just do here, I could just copy paste. Oops. Oh, I'm a little clumsy today, huh? What I could do here, I could just say, can I just return directly this message that I have composed? All right. And then this would work exactly the same. If I execute this, both things will work. And similarly, here in this program, I could just, for example, instead of creating the message and a string variable and printing it to the console, I could just directly print to the console the result of greeting Jose Luis. Remember, the way this would work is that this would get executed first. It would turn into a string message with the hello and the exclamation mark, and then it will be printed to the console directly. This approach might be easier if you don't need to keep the message for reusing it further into your program, if it's going to be just a one-off, okay? Then maybe you just don't want to waste the memory of declaring a variable for that. All right. Okay, so let's move on to the next video, and then let's talk about other topics related to functions. All right. Okay. I need to go to the restroom. I'll be right back. Give me a minute. Don't go anywhere. I'll be right back. Okay. How's everyone doing? Oh, there's conversation about parametric design. Alrighty. Oh yeah, well, AMR Masood, yes. Grasshopper and Rhino are one of the most popular environments right now to start parametric design. We actually have a bunch of videos in the channel uh, about Grasshopper and Rhino. I was halfway through a introduction to parametric design, but I got distracted with this playlist that we're doing right now. But I will, once we finish this one, learning C sharp, I will hopefully go back to learning Grasshopper and teaching that. Mm-hmm. Or if you're into Revit and BIM, then perhaps you want to give it a try to Dynamo, which is a very similar paradigm, visual programming, but it integrates really well with with Revit, for example. So, all right. So, how is my sound? Okay, I want to ask you, how is my sound today? Because I am using a new noise reduction filter, and the testing that I did in my recordings, it sounded really well, but I don't know how does it sound live. So what is the sound quality right now? How are you feeling about that? And the volume, how is the volume? Is it good? Is it too low? Can you let me know what you think? All right, the next video is going to be smart comments. We're going to do that. Oh, also, I need to change my, because I can't, all right, yeah, because I can't do, oh, yes, no, I need to change that, because I was trying to comment the line, and I usually use control /, and because this is a new Visual Studio, I couldn't really, so for keyboard, I need to configure, what is it? Comment up. Where do you go? Where do you go? Comment selection. No. Insert comment. No, I want comment line. Advance. Toggle line comment. That's what I want. Yes. Yeah, so I want just one key for that. Toggle. This one, toggle line comment. So I want for the text editor, I want this one. That's what I want. Well, did I click assign? Do you have to click assign? Toggle line comment. There you go. Yes, we have to click assign, otherwise it doesn't go through. No, I want it in the text editor. I want this here. Sing? No, I'm not going to sing anymore. Nope. No, I'm terrible at that. Okay, and I'm going to move line, move edit, move control, move selected lines down and selected lines up. So that would be like this. Yes, so that's what I want to do. So I want to, and what, yes, I want that. Maybe a bit higher. What do you mean? No, that the volume should be higher or that is too high? Move line. Yes, so in the text editor, I want to move them down. Assign that, and I want to move them up, so I want to assign that. Okay, and therefore now I can move them and I can cut. Still no comments? What is going on? Toggle. toggle line comment. But for the text editor, I want this. So I want to assign that. Okay. And therefore, this is what I want. Exactly. Very good. So where were we? We were saying creates a greeting message and then adds two numbers. And then here I want to say message, and that's going to be that, and that's going to be here. Okay. All right, so I'm going to talk about documentation comments now. I'm going to talk about documentation comments. I'm going to do that by describing that those comments are great, but they're not as useful, and describing the C# way of doing that. All right. So you think it should be louder? Is that what I hear? It's very loud. It's almost like in my OBS. It's like at the it's always hitting like the red mark. How are we doing? Oh, okay. All right. Let's get rolling. Before we talk about more functionality of functions, if you will, I wanna explain like a really nice feature of C#, which is documentation comments. Okay, and the idea is that when we write comments, we have talked about comments a lot. Comments are super useful, and we really it's the really good practice to write. But there's actually special ways and special styles that we can use to make comments even smarter and more relevant within the program. Because, for example, for the two functions that I created before, I just added like a simple comment here. This creates a message. This adds two numbers together. But we don't get, if I were to write here, for example, addition, you see, as I start writing, the helper text, the highlight text here, the IntelliSense text, only tells me, only gives me a description of the signature of the function, but it doesn't really tell me anything about the function. There's no helper text, if you will, as opposed to, for example, if you remember, if I say math.square root, you see how there is like a nice description here about what is it, and then when I open parentheses, there's a nice description of what is the first argument that I need to pass in, the number whose square root is to be found, right? So I want to be able to write comments because I'm writing functions are code that will be reusable and modular. So we want to give people as best as a helper description about how that function works so that it's even more modular and more reusable. The way to do that is by using documentation comments, which is a very C# specific thing. Other programming languages have their own ways of templating or creating formats for documentation comments. But if we are in Visual Studio, Visual Studio by default already helps you a lot with those smart comments. So for example, let's say that I wanted to add a nice documentation comment to this function. Instead of using a simple double quotes, the way we would do that is by starting with three forward slashes. So I would write here 1, 2, 3, and you can see that immediately this template shows up with this open and closing tags and with like parameter, blah, 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 and what it returns, etc. So this is a template that I can use so that anything that reads C# code can read these comments smartly, and then they can give you those intelligent suggestions. So for example, here I'm going to write adds two numbers together. All right. And then here in between the two parameter tags, I'm going to write the first value, and then here I'm going to write the second value, and then in between returns, I'm going to write what is it that this thing is returning. the added result. Okay. If I do that, and if I write my comments this way, then check out what's going to happen in my program. As I start typing addition, you can see that now here I get a nice formatted text, which is the description of the function, basically what I wrote here, right? So I'm going to press tab and I'm going to open, and you can see that value A tells me that it's the first value that I want to add. So that's going to be whatever, 24, and the comma is the second value that I want to add. So that's going to be this thing here, all right? And then as I do that, this is going to work, but you can see that my programming experience as an user of these functions was much nicer now, right? So documentation comments are really nice when you are designing code that should be reusable for other people, but also for yourself. Because trust me on this one, when you write a function and you don't use it in 2 weeks, you're going to forget what that function did and how it worked. So writing comments also for your own future self is a very smart thing to do. So for example, for here, I would just say creates a greeting message for a name, and then here like target name, and then the result, the greeting message, right? And then as I do that, then now here I get greet, and you can see that I have the nice helper text and then the target name, etc., etc. All right. So my recommendation to you is that as much as you can, please use documentation comments because they're really helpful. And as soon as the project starts getting complex, your future self is really going to be grateful about the extra time that you put in writing nice documentation comments. Okay? I think you're right. I think it's a little low, but that's because I'm having the noise reduction, and the noise reduction is basically cutting out all the background noise, and therefore you don't hear like all that extra loudness that my neighbors and that kind of stuff. But I'm not sure I want to crank it up too much more because I'm already, as soon as I talk like now, I was already on the red bar area. So, and that starts clipping the sound and all these bad things. I'm not sure. I'm going to let you vote if you think I should crank up the volume more or less. At least for today, I'm going to keep it as it is, just because I want all the videos to have the same consistent noise volume. All right, so that one is done. And then documentation comments, and then scoping in functions. Oh, scoping in functions. Yes, so how can I talk about that? How can I talk about scoping in functions? I would like to. All right, I'm going to create a new project. Can I save this project as with a different name? I'm going to have to create a new one. All right, Visual Studio, blah blah blah. Create a new project. It's going to be a console application. I'm going to call it 42 function scope. Stop it. I need to get a new keyboard. Function scope, and it's going to go in the desktop. 4.5 is great. Okay, and I'm going to copy paste a little bit of the code here. So I'm going to do some of this. Going to go here, and it's going to. What am I going to do? I'm just, you know what? I'm actually going to not use this, and I'm going to say I'm going to write a function that is going to be static double circle length, and that's going to be the radius, and then what I'm going to do is I'm going to calculate the length of a circle, so that would be double len equals 2 times math pi times the radius, and I'm going to return that length. And here, for example, I'm going to say radius is going to be 1, double length is going to be equal to circle length is going to be equal I don't want, by principle, I don't want to write things with very similar names to just not make things confusing. Circle length is going to be equal to circle length of the radius, and then let's print this to the console. Sounds good, Lara. Thank you. I think I'm going to keep it like that, yes. And then this is going to pop up all the way here. Properties. Wait, we were on 24. Yes. So can I save that for? I wonder if I could do that. Okay. All right, that's fine. So I'm going to start here, and I'm going to talk about circle scoping. Okay, no, but do I want to do that like this? Or actually, I may not want to do this. I'm not going to do this right now. I'm going to start with a different example. I'm going to start with something similar to what we had before, which is this. Actually, they should be A and B. They should be A and they should be B. It's a beautiful day here in Boston. It's a perfect day to go for a run. And here, I'm going to do this. And I'm going to explain that I cannot read here from these two values here. It's also terrible practice for the rules of scoping. Yes. Okay, let's do that. Okay, let's talk a little bit about the rules of scoping when it comes to functions. Remember, in previous videos, we talked about how variables have this property called scope, which means that their life expectancy and their accessibility, so who can read them or not, depends on which scope they were declared in. And remember that when we talked about C# in particular, for example, we said that blocks and scopes are defined by code blocks, which is this thing that is always wrapped inside of curly brackets. So any curly bracket will define a scope. Okay. Now, why is this important? Well, you may ask yourself like, we were defining a function by writing the name and then writing here these like two arguments, which are like the placeholders for the inputs that are coming, etc. But this sounds like a little overcomplicated to me. Why do I have to actually even pass these parameters, etc.? Why not just do something where here directly what I do is I just say, I'm just going to take the value of A and the value of B here, and then here I don't even need to just create a simpler function that just does the addition and takes the value of these two values here and adds them together. You may ask yourself, why am I not doing that? Well, there's two main reasons why we don't want to do that. The first one is technical, and it is the fact that because this code here is defined in this scope for the function, in the scope defined by the function. And because this scope is different, is at the same level, but is different from the scope where A and B are declared, what that means is that A and B are not visible, are not accessible from this scope because they are in different scopes. Remember, A and B exist here, but then they stop existing after this curly bracket. So when it comes to this function, they are not available anymore. And if you actually look at the error message, they say that A doesn't exist in the current context, in the current scope. So technically, we can't do that. We cannot see A or B from this function. And that's why we need to do this thing where we create like an entry point. We create like we open two doors for anyone to throw in data at the function. And then those two doors have those names here, and we can operate with them inside of the function. All right. Otherwise, we would not have access to that information. The other reason why we want to do that, the other reason why we want to do this is because with what I showed before, it would be considered pretty bad practice when it comes to computer programming, because what if the main principle behind creating a function is creating a piece of code that can be reused by as many parts of your program as possible. But if I make a function, for example, addition, unique and particularly useful only for these two particular variables A and B, if I link them together in this way that I did before, then basically addition would become useless for any other two variables that I would have in my program. And therefore, if I'm going to be using a function that is extremely dependent on only two variables, then why do that? Why even bother? It's actually not very good practice, okay? But you may, so that's more the conceptual reason. Now, there might be situations where a function may actually have access to external data that has not been passed into explicitly as an argument. All right. And what could that situation be? Let me show you an example of that. Let me write it, and then it's going to pop up here in a second. Wait for it. All right, and now we are going to replace that with this. There you go. So take a look at this example. What I have done here is that I have created this one variable, this one function, sorry, that given the radius of a circle will compute the length of that circle, the perimeter, right? And we know that the equation to do that is 2 times pi times the radius. Just like the area would be pi times the radius square, okay? And then here in the main function, we can declare the radius, we can calculate that, and the result would be something like this. So you can see that the value of this is 2 times pi, 6.2831, etc., etc. Now, if you know me a little bit, you know where I'm going with this. And you know that as much as I respect pi, I'm very much a Taoist, and I believe in Tao as like a nice constant, like 2 times the value of pi as a much more reusable thing. You're welcome to check out taoday.com or something. It might be popping up here, or just like Google it. But anyway, imagine that we were using this function a lot, and we just wanted to optimize it like a tiny bit, right? Because this function will always be using 2 times the value of pi. So what we may want to do is we may want to pre-calculate that value just once. And then if we're calculating this like a million times, then we're basically saving ourselves a million times calculating the same value, 2 times the math pi, right? So we may want to apply like a tiny bit of optimization. So what I may want to do is I may want to create a variable that I can call tau that is going to be 2 times the value of pi, and then make that accessible for everyone in my program. Where would I do that? Well, I would not be able to do it here. I would not be able to say tau equals 2 times math pi and then use tau here. That is not going to be possible, and it's not going to be possible for the reasons I just explained right before. Tau, if it's declared here, it will not be visible in this other scope, which is at the same level. So if you remember from the rules of scoping, things are visible either if they are within the same scope or on a children's scope. What that means is that if I want tau to be visible here, well, something that I can also not do is just do it here, because if I do that, then I'm defeating the purpose. I would still be, if I'm calling this function a million times, I would still be calculating the value of tau a million times. So I haven't really fixed anything. So what I need to do is I need to place that new variable, tau, somewhere that is accessible for the rest of the program, for everyone in the program. And that place is going to be the parent scope where this function is going to be living. So that is going to be either here, which is at the same level, or even better, typically you would write all these things like at the very, very beginning of your class, okay? Which we will see why this is farther down the road. And this is still not working because, and you will have to trust me on this one until we get there, the only thing that I need to wrap up is I need to add here the keyword static, okay? When we're writing console applications, all our variables and all of our functions should always be static, okay? Therefore, now, because my parent scope has a variable that is called tau with this value, then this function will always have access to the value of tau. Not only this function, but any other function that I may write in my console application that would use 2 times the value of pi, okay? And therefore, now that there's this access, and then this value can be used for any function, okay? Now, I want to highlight like a quick thing before we move on, and it is the fact that because, and again, under the philosophy that functions are designed for modularity, for encapsulation, etc., some people may argue that this approach, the fact that this one particular function is dependent on the fact that in the program that it lives in, there is a variable that has to be called tau and that has to have this value. People may argue that that is not great practice because basically this function is not purely modular, it's not purely encapsulated anymore. This function will only work if it lives in a context that has a variable called tau with this value. And therefore, if I were to copy paste this somewhere else, and I forgot that that somewhere else need to have that tau, then this function will not work, okay? So there is a balance between how much encapsulation and modularity and how much you don't want to have it for the sake sometimes of performance. So if this function is going to be living, for example, in a very complex project that you're writing, like a library of code, and a lot of your own functions are going to be depending on tau, then because you are managing that, then maybe it's okay because you're saving yourself tons of calculations. But if it's something that is really need to be shared and moved around, then maybe this dependency for this function is not a very smart design choice, okay? So that's going to be something that you will have to decide as you are creating more complexity in your programs, okay? All right, let's move on to more function topics. All right. Okay, so that was scoping in functions. And what we're going to do now is the return type, the void return type. So functions that do not return anything. We're going to take a look at that. And then we're going to do function overloads. How's everyone holding on? Where's my water? Harás tú. What is that smiley face? What are you laughing at? Okay, so this is here, function scope. Um, okay, so what I'm going to do is I'm going to create a new, I'm going to create a new project. It's going to be a console application. That's going to be 43 void functions. Create this. And then I'm going to copy and paste some of this code. So that's going to be here. And then okay, and if I run this, okay, yeah, the phone's gonna be 24. Yeah, this is not. I'm going to have to find a way to make these changes permanent. How do I open multiple instances of Visual Studio? I press Windows key S. Oops, sorry, no, not that one. Where did everything go? Where did everyone go? I press Windows key S, and then this thing shows up. I can move this into this window. This thing shows up that allows me to type in the program that I want to run. So I just start typing Visual, and then it gives me, it tells me like, oh, you want to run Visual Studio? Or if you have an icon on your desktop, you just click again and it opens a new instance. Okay. All right, so I'm going to talk about functions that do not return anything. Well, I would like now to take a moment to talk about a very particular subset of functions, the ones that actually do not return any output type whatsoever. And why is this the case? Well, it turns out that as like the majority of the functions that we will be writing will be using this paradigm of taking some inputs and returning some outputs. Okay, and but they will not really change anything in the actual program. But very often, some things that we may want to do is we may just want to call a function, give it some information, but then we may not just want to do anything with the return type. We may just want that function to change something in our program, either to change values of certain variables, or we may want the function to print stuff to the console. We may want the function to draw things on the screen if we're in a graphical environment. There's like many situations where we may actually not be interested in any outcome coming back from the function. So those functions are typically referred to as void functions, or functions that do not return anything. And a nice example of that could have been the function that we wrote before, which was a little strange because we basically, what we wanted was just to print to the console a message greeting someone. If that's what we wanted to do, then it was a little tedious to have to call the function, write this into a variable, and then like console write line the value of that variable, right? Why not just create a function that directly takes that name, creates the message, and prints that to the console right away, and we don't have to care about what it's giving me back, right? So the way we can do that is very simple. So let's take the grid function. We're going to leave the arguments the same. It's going to take a name. We're going to leave what it has inside also the same. is we're going to create these matches. But then inside of this function, what we're going to do is that we are going to directly, inside of this function, we're going to right line the value of that message. Okay, so whoever calls greet is going to get the effect of the text composition and that message printed to the console. But at this point, we are actually not interested in giving anything back to whoever called this function. Now I have a problem, and the problem is that because I specified that this function needs to return a string, the compiler is complaining because there's nowhere in my code that I am actually returning that string. So what I need to do is I need to change the return type, and instead of the return type being a string, I need to specify that this function is going to return absolutely nothing. But how do I do it? What is the data type for nothing? What does that look like? Well, we have a special keyword in C# that is called void. All right? And the idea is that void is actually a keyword that denotes that nothing is going to be returned. And look at what happens. I actually don't have any return anything here anymore, and the compiler is just not complaining anymore because void signifies that nothing needs to be returned. What has happened though is that now I have a problem, which is that this is giving me an error because the way I have written this line, it is expecting that greet is going to return to me something that is going to be of the type string that I can store here. So this code is not valid anymore. And then what I need to do is just simply remove all of this and then just say, I'm going to call the function greet. I'm going to pass it a name. And then that's it. I don't need to care about anything else. I don't need to store the result in a variable. I don't need to console write line it myself because all of that is taken care of by the function. As I run this, you can see that I can call greet. This gets printed to the console, etc., etc. So actually, for example, a trick that I use a lot is that I find it very tedious. I print a lot of things to the console very often, but I find it very tedious to have to always console write line, blah, blah, blah. It's kind of a lot. So a trick that I typically use is that whenever I'm writing console applications that I'm debugging, I actually just add like a bunch of functions to help me write code a little faster. And one of them is typically a function that I call log, just like a very simple log, which takes a string, which is going to be a str, and the only thing that it does is literally console write line that's that str. So for me, that is a very simple way of now saying, oh, I can just press log hi there, and I save myself all the hassle of the console.write line, etc., etc. All right. This kind of pattern, the pattern of taking a function that it already exists and wrapping it inside of another function that has a different name, is typically called a wrapper, or is typically called an alias. So I basically created a function that does the exact same thing as console write line. It just has a different name. Okay, but yeah. So you can see, and there's these kind of functions that do not return anything, again, are very common when you want to interact with the console, when you want to interact with your graphical screen, when you want to draw things, etc., etc. All right, you will see them a lot. Okay, I just had an idea, and I'm going to add something to the list today, which is going to be, I'm going to talk about this. I'm going to talk about how a console application is a function that takes arguments and that uses them. And I'm going to show an example of that. That's going to be really nice. Console apps and the void function. Okay. Ooh, all right. So let's do that. Should I do that right now, or should I talk about function overloads first? You know what? I actually think I should talk about function overloads, but I should do it like right after scope, right after documentation and before scoping. Function overloads should be here, scoping functions, the return type, and then I wrap it up by talking about this. So that's kind of like a nicer structure, I think. Yes, I guess what I'm saying is that I want the videos to be like this. So I want enter the function, the return types, documentation comments, function overloads is what I'm going to be doing now. Then it would be scoping in functions, which is what I just did, the void return type, and then console applications and the void. So I like that. So let's just, this is my OCD kicking again, okay? So I have this, I have this, I have this, this, and this, and now function overloads and console apps. Alrighty, that sounds like a plan. Rodolfo, what is nice? What did you just like? Arastu, Tau. Yeah. All right. Of course, of course, it was going to be a Tau example. How else could it have been? You know, could it have been? Okay. Function overloads. How are we going to do that? We are going to void functions. Okay. So that's going to be function overloads. It's going to be on the desktop. And what are good examples for function overloads? Well, addition with a bunch of numbers. I did have some notes from my class. Wait. So we had, okay, overloading, addition. Oh, yeah. Yeah, we can do addition for 2 values, 3 values, 4 values, or an array of values. How awesome is that? So I think we're going to do that. So the way we're going to do that is by saying double A equals 5, double B equals 7, double C equals 12, double values is going to be a new array, a new double array with 5 elements. And I think this is how you initialize. Is this how you initialize? Yes. And then I want to add those together. Console read key. And then I'm going to copy paste this here. Okay. And then double sum A and B is going to be addition of A and B. I think this is probably what I want to start, and then I want to build up to adding 3 values and adding the whole array. And this is going to be called nums. Okay. All right. We're not going to have time for the longer exercise this morning. It's fine. That's fine. That's perfectly fine. All right, let's start with function overloading. All right, the next topic that I would like to touch upon is called function overloading. And the idea is that functions have a very special property, which is very nice, which is the fact that you can actually write several functions as opposed to variables, for example, which have to be unique and you cannot repeat their names. When it comes to functions, you can actually write several functions with the exact same name so long as the argument number or the argument types are different. AKA, so long as the signature of the function is different. And let me explain why would we want to do that. So for example, let's go back to the simple example where we were adding two numbers, right? I just created this console application that has three variables for three independent numbers, and then it has another variable for an array of numbers, of integers, for example. And I'm not sure if we have seen this in the series, but this notation, especially this part, is creating an array on the fly with 5 empty slots, and it's populating those 5 empty slots right away with values. Okay, so this is like an inline assignment. I forget how that is named, but basically I just initialize the array with those 5 values as opposed to using a for loop to like you create. You know where I'm going with this. Okay, and then here I have a variable which is going to be the addition of a and b. Now, let's say that I wanted to create functions that were able to add two numbers, but also three numbers or four numbers, or I don't know, or any, or even an array of numbers, okay? If function names had to be unique, it would be a little tedious because then I would have to rename this addition to values. And then the next function, the one that adds three values, would have to be called addition three values. And the one that adds all the values in an array would have to be called addition array or something like that. So it's not very clean. And because C# is strongly typed, and because it knows the types of things that are coming in, then I actually have the advantage that because the compiler is smart enough to know what variables are going in, this compiler will be able to choose which one is the right function to call. So what that means is that I can actually create several functions with the same name so long as either the number of arguments or their types are different between each other. And therefore, I could use the addition function for two values or three values or an array of values. The way that looks is like this. Let's say that I wanted to create a second version of the function, the addition function, that takes in three numbers. The way I have to do that is very simple. What I do here is I say static double addition, and then I say double A, double B, and if I left it like this, and I'm going to copy this here. If I left it like this, you would see that this is complaining because the program already finds a member called addition with the same parameter types, with the same amount of arguments and their types. So a solution would be, well, I'm just going to change how many arguments my function takes. So I'm going to add a third parameter, which is going to be called C, for example, and I'm going to use that here in the computation. And remember that the fact that these are called A, B, and C, and these are called AB or A, B, and C, is absolutely a coincidence. It's actually, I should have actually named it different to avoid confusion. They do not have to be called the same. But now you can see that now I don't have a name conflict. I have a variable, a function that takes two numbers, a function that takes three numbers, and as I type, for example, sum A, B, and C, if you start typing addition, you can see that I have something very interesting now. It tells me that the function has two different overloads. So for example, here, and you can see that I have a version that takes two arguments and I have another version that takes three arguments. The IntelliSense is already completing this here. So I can say now this A, B, and C, and then the result is going to be the addition of those three. Similarly, I could write here static double addition. And then if I wanted to create a overload that takes an array of numbers and adds them together, then the only thing I would need to say is like I would need to add here a parameter called values, for example. But remember that I need to specify that this is not one single number. This is an array of numbers. And therefore, here I could write some code to put those together. So for example, I'm going to copy, paste it. I'm going to do it. So I would create an empty variable with an empty initial value called 0. And then I'm going to, with a for loop, I'm going to iterate over all the values in the array. So values.length, I++, and then sum, to the value of sum, I'm going to add each one of the values, one at a time. And then the return type of this, the return value is going to be the sum of all of those. And now, here, I can just say sum level, sum array, it's going to be equal to the addition. And now I have 3 overloads, right? So I have the array of values, 2 numbers, or 3 numbers. And then here, I would say I want to add all the nums. And let me see if I can print this to the console. So sum A and B, right? Oops, nope. Let me copy and paste this, A, B, and C, A, B, and C, and the array. And if I print this, you can see that, oh, it's giving me 12, it's giving me 24, and it's giving me 30, which is the addition of all this stuff here. Okay? So overloads are very, very useful. Overloads are very, very useful because they give us the possibility of creating similar functions that have the similar names, but they take different kinds of arguments. And this is usually a really good practice because it gives people who are using this functionality flexibility to choose which inputs they want to use. Okay, this is a very, very common technique used in computer programming. Let's take a look at more function features. Alrighty. Oh, I think I just responded to your question, Monique, right? Yep. Arasto, can I do this? Is this valid code? Oh, I had no idea this was valid code. I think they are the exact same thing. I'm actually used to the Java way of doing that, which I think is how I wrote it before. But I had no idea you could actually write this way. That's kind of nice. Thank you for that. I think they're identical. They're the exact same thing. I don't think they change. Okay, and last thing we're going to touch upon this morning is going to be what is it going to be? It's going to be the it's going to be the console application as an actual function. I think this is actually kind of more elegant somehow. I like this better. I'm going to incorporate this into my programming life. What else? What else? What else? Yes, so Visual Studio. Console applications, and this is going to be 45. Console app as function. And how am I going to show that? I'm going to have to show this here. All right. And here, where's everyone? Okay. And here, And in binary, so yes, a console read key. Actually, no, I'm not going to do that this time because I don't want that. Well, actually, if I, so right line, and then if I build this and it shows up here, it has this really nasty name. I don't want that. So let's just not do that. Let's create a Visual Studio project that is going to be called greeting. Just simply that. So that when I call that in, and also I don't have opening. I don't have open here a console terminal, which is gonna suck. But I can do that anyway if I just copy the route here and I just open a command prompt and I just say cd this. And actually, well, I open the command prompt and it's already in the desktop, so that's kind of nice. That's kind of nice. Is it? It is. I can also use PowerShell, right? Yeah. CD desktop and then cd create. There's nothing like that. Yes. Okay. All right. So I'm going to remove this then. And then this video, where is this video going to go? The void return type. So here. So I'm going to start. I'm actually going to do the whole thing from this, and I'm going to build it as I go because I think it's interesting to create the application, to specify the name, to say where it's going to live. Oh, and I could do also an addition of two numbers. That could be interesting. Okay, I'm going to do that I'm going to do that in the program. I'm going to do that in the video while I'm recording. All right. Are you excited about this one? Is going to be the nerdiest video of this section. So I'm going to teach you how to actually bundle a console application and call it from the command line. It's going to be really, really cool. So what is it going to be? Yes, so I'm going to start by I know, Kartik. I'm sorry. Like it's a really busy semester for me. I can only do Saturdays. But I told you I wouldn't take it personally if you chose Dan over me, you know? And where is it? Okay, so I'm going to start talking about how this. We just talked about the void function, so I'm going to talk about how console applications are actually a function, and they take an array of strings. Okay, so and then I'm going to build a project that is going to just greet someone, and then I'm going to build another one that is going to print numbers to the console or to add them together. It's going to add them together. It's a bit easier, I think. Okay. Now, you want to go a little nerdy? You're going to love this. I think you're going to love what I'm going to explain to you right now. So we just talked right now about how there are special functions that are void functions, empty functions, and functions that take stuff, take inputs, and do not return anything. They just do something. They just change the state of the program or print to the console or do graphical stuff. Now, you may have noticed, now that I wrote those two examples, you may have noticed the similarity between this static void thing and the typical structure that we get whenever we start a new console application. And alas, now finally we were able to understand exactly what a console application is. And turns out that a console application is just simply as simple as a function that has a very particular name called main. And that's why the console application knows that is this function that it needs to run. And it's a function that doesn't return anything. So whenever I execute a console application, what my Visual Studio environment or my .NET framework is doing is it's looking for that main function and it's executing whichever code is inside of it. All right. And that's the reason why if I now press start, the .NET framework knows that in this code that I write, it needs to start by executing this main function. All right. Now, but wait, what does this have to do with an actual console? Why is it a console application and not just an application, right? Well, it turns out that console applications are specifically designed to be executed from a terminal, from a console. It's just that when we are in the Visual Studio environment and we click continue, or we hit start, Visual Studio takes care of like opening this console for us and executing this right away. But we could actually do that manually ourselves. Additionally, perhaps the most interesting feature of a console application is that a console application can actually take arguments. It can actually take input data. But why would, and the type that it takes is an array of strings. Wait, why is that the case? Well, it turns out that console applications, because they are designed specifically to be executed from a terminal, they are meant to be executed as the name of the function, so a name of the application, and then with a bunch of spaces, all the data that you want to provide to that console application to work with. And then when the terminal executes this function, this console application, it takes all of those additional elements, it puts them together as an array of arguments, and then it passes those in to the console application. What the hell is that? That is a lot of stuff. Okay, let me show you an example of that. What I'm going to do is I'm going to open a new Visual Studio project, okay? And I'm going to create a new project. And this one, I'm not going to give it numerical names for the video tutorials that I'm doing. I'm going to create a console application, and I'm going to give it the name of a function that I would want to use in my console. I'm going to create a console application that, given a name, it greets in the console the person with that name. So the project name, I'm going to call it greet, just like the function that I created before. And I'm going to put that on my desktop. This will be important so that you know where this lives, and then you can access that from the terminal. I'm going to create that, and I have an empty console application. All right. And then what I'm going to do is in this application, what I would like is I want someone from outside to do something like this. In the terminal, I want them to type greet and then, for example, Roger or John or whatever, right? And then what I want is after, I want the program to type in the console, hello, John. So what I would need to do is I would need to say here, let's take from the string of arguments, let's take the first one and use that to print that name to the console. So what I'm going to do is I'm going to say console.writeLine, and I'm going to print here, hello space plus the first element in the argument list. So args.0 plus the exclamation mark. All right. And that's going to be it. I'm not going to do the read key, whatever, because in this case, I'm not interested in waiting. It's not going to be for the screen. It's going to be for the console. So this is going to be as simple as this. I'm going to execute this program, and you won't even see it because it just flashes, it prints. Well, it actually fails because it was executed with no arguments. When you run a console application from Visual Studio, no arguments are passed here to the... So this array of strings is empty. So that's why I'm getting an error here. But let me build this code. So what I'm going to do is I'm going to take this console application and I'm going to build it into something that can be executed by my system. And the nice thing is that if I open now my Visual Studio folder, the project, remember it's on my desktop under the folder grid. If I go inside and I go to the bin folder and to debug, you can see that Visual Studio has created an executable that is containing this console application. This executable is something that I could just run right now and it double click, but you can't see anything because it had an error, it just flashed away, it's gone. But what I could do is I could open a terminal. So if you do search in your computer and you search for a command prompt, you will be able to open a tiny window like this, which is a terminal. And this gives you access to what is in your system, etc., etc. Something that if I want to execute this greeting program from my terminal, what I would need to do is I would need to first move to where this program is living. And this is, you can do that, but if you click here in the Explorer, you can see the full route, the full path of where this program is. It's in my desktop under grid, the bin folder, and the debug folder. So I can do that by saying cd and then paste here all this stuff. As I do that and I press there, you can see that I can see my 3 files now, the ones that I'm seeing right here. And are you ready for this? Check this out. What I can do now is I can type here grid.x, which is the name of the function, and then I can pass in a name, for example, John. And then as I execute this, you can see that to the console, I get this message printed, hello, John. Or I can do this and say, hello, Jane. And then Jane shows up here. Or I can say, hello, Jane, James, Robert, etc. But I only get the first one in. So maybe what I want to do is I want to improve my program and be able to greet everyone that has been called in the line of arguments. Remember, what Visual Studio does, or what your system does, is whenever you call greet, it takes anything that comes afterwards, it splits anything that is coming with white spaces, and then it creates an array of strings with all that information. So here, we actually have, when we call this, we have an array with all those additional parameters as a list, as an array. So what I can do is, if I want to greet everyone, what I want to do is I want to say, I'm going to iterate over each one of the strings that have been passed. So I'm going to iterate over all of this. And then inside of here, instead of only writing a message for the first one, I'm going to write a message for every single one that is available on the array of arguments. I'm going to build this solution so that I compile a new version of grid. And then here, I'm going to repeat this by pressing the up arrow key. And you can see that now my code with a for loop is going over each one of the strings in the arguments array and is printing that to the console. And similarly, I could do more of this and it will print a value for each one of them. Or I could even just not pass anyone in because the array would be empty. Then my program doesn't really do anything. Okay? How awesome is this? So you have now the power to create your own console application, your own terminal applications very simply. Now, can we do something, for example, where we can add addition and then add the value of 23 and 56? Something like that? Can we add two numbers? I'm actually going to call this add. All right. Obviously, we don't have this right now, so it's not going to work. But can we create that? let's just take a look at that. So I'm going to create another Visual Studio project. So I'm going to open another one, and I'm going to do, oh, what just happened here? I'm going to open another one. What is my Visual Studio? Where did it go? Oh, I have a lot of windows. Sorry, Visual Studio. I'm going to open a new project. It's going to be a console application. This one is going to be called Add, and it's also going to be on my desktop. And then what I'm going to do is I'm going to write here an algorithm that given any amount of numbers from the console, is going to print them, is going to add them together, and is going to print the solution to the console. Now, the way we would do that is just like I had before. And actually, why not reuse one of the functions that we created before? I'm going to say that the addition of a stream, I can use the addition of an array of values. Actually, I cannot use this one because one of the problems is that even if I may want to call this function with numbers, it turns out that the terminal, when you type stuff, the terminal doesn't really know if what you're typing are numbers, booleans, doubles, whatever they are. So that's why the type of the array that is coming into the console is always going to be of a string, because then from a string I will be able to try to convert that to whatever. Okay, so what I'm going to do is I'm going to say double sum is going to be equal to 0, and then with a for loop I'm going to go over each one of the elements in the array, so args.length, etc. And then remember, I cannot do this. I cannot add to this double, I cannot add each one of the elements in the arguments. What I need to do is first, I need to see if I can convert them from a string into a number. So what I would do is I would say value, and then I'm going to use, for example, convert to double, and then I'm going to convert each one of the values. And then if that works well, I will add that value to the total sum. And then here in the console, I'm going to right line the result of the sum. Or even if I want to be a bit more specific, your total is like something like this. Let me build this solution. Let me go to my desktop and find where the bin folder with this is. So this is going to be the route. I'm going to type here cd and then go to that route. And then if I type there, you can see that now I have the add functionality here in this folder. I'm going to type cls to clear the screen. And then now I can say add.x, and let's add, for example, the value of 2 and 3. Your total is 5. Well, let's value 3 and 7 and 6 and this really long number here. And because I'm using a for loop to go over all the arguments, I can add everything together. Can I add values with decimal part? Of course I can. If they are parsable, why not? So I can add values with decimal part. We just need to be careful, okay? And we just need to be careful. Why is this not working? Just need to be careful, because if I happen to just add something that is not a number, the conversion will fail, and then I will get an error. So this will just crash. It will not work. It's not a terrible error, but it's not a great one. All right. So remember, console applications, in fact, under the hood, they're just a very, very simple function, a function that returns nothing, and that takes an array of string arguments, which is whatever has been passed as arguments to whoever is calling this console application. And if you just want to use this not just to learn C#, but to actually create code that you can call in your system and operate with, then you can compile, so you can build console applications, and then you can call them from your terminal, from your command prompt, okay? And that is why really console applications, that's why we have been using console applications, and that's why they're the simplest form of executable code, all right? Okay, and I think with this, we might be finishing the section in functions. So the next video is going to be just an exercise where I'm going to be writing a lot of different functions that are going to be doing a lot of different things. So if you want to practice what you've learned in this section, let's move on to the next video. All right. Okay, I think that's going to be it for today. So where? Yes, here. All right. So I'd ask to, is there a way to wrap an integer inside a double data type for a quick division? Like for creating divisions for ratios or proportions? I'm not really sure what you mean. Why would you not? Why would you want to wrap an integer into a double? I am not sure what you mean. You can, so inside for loops. Is there a way to wrap an integer inside a double data type for a quick division instead of using the convert methods? Can you give me an example of what would you like to do? I'm not sure if I follow. Well, while you're typing that, I think this is going to be it for this morning. I'm very hungry, so I'm going to go have lunch. We are going to be back at 2 p.m. And I think what I'm going to do is I'm going to write an exercise, so like a bit of a longer video, which is going to be just functions, different types of functions, doing different things. And then if we have time, I will do a geometry gem. I think it's going to be either points of grids, or if I don't have a long time, if I don't have much time, then maybe I do like an exercise of like plane, changing a plane from one place to the other. I'm not sure about what I will do. We'll see, depending on the time that we have. Okay. I'm actually quite happy that the whole setup worked and that we didn't have any major issue. I'm going to check the volume of the video as we hang up. But for all of you, well, we're going to call it a day. Thank you very much. And I'll see you in 1 hour and 45 minutes, 2 p.m. Boston time, if you're interested in this afternoon's live stream. Okay? Like we have the length for a line. If we want to place a point at smaller parts of it, we made a video about that. We made a video about how to find a point along a line. You may want to check out the geometry gems for that, or us too. All right. Okay, thanks a lot. I'll see you later in the afternoon. Bye-bye.